All right, good morning. Good morning. Happy Friday, guys. Okay, so we have one more thing to finish before we are done with this section. There's a lot of information. Some of it is, well, a lot of it is review, but it's super good for us to talk about this. Okay, so we talked yesterday on example number 4 about absolute max and absolute min. Be careful. We saw that even though this, oh gosh, even though the point may be the lowest, it doesn't necessarily mean that it is an absolute max or an absolute min or even a local, because we have to be careful. It has to, by definition, be changing direction. Local, we can have more than one. Absolute, there is only one. We weren't able to finish with the intervals, so take a look. Here are answers, and then domain and range. Intervals are areas of space for decreasing and increasing, so don't forget we don't use the brackets. Whereas domain and range, they are inclusive, or maybe not, but here they are because it's a closed point, so that's why we use the brackets. And then it is neither even nor odd as a function because it's not symmetric about the y-axis or the origin, so we write neither for E. One little change I want you guys to make, I think I went a little bit too fast, my bad, sorry, on your notes. If you go back to the definitions, we talked about average rate of change. We know it to be slope. But I actually would like you to separate the difference in y over the difference in x with the triangles. Remember, it means difference, and then have it equal to the actual differences. Okay, so just make that change on your notes, please. And thank you. Okay, last thing we need to look at is the slope of the secant line theorem. Okay, so we know that slope is m. And we know that SEC, the subscript down here, is going to mean secant. Well, a theorem is something that was proven true. So back in the day, there were mathematicians who were trying to figure out what the average rate of change was for a curve. Well, average rate of change can't apply to a curve because it's a constant change and curves are growing or decreasing exponentially. So what they did is they created a secant line. A secant line is a line that cuts through a curve at 2 points. Okay, we see it with circles normally, the secant of the circle. And what this says, let me change my pen real quick. What this says is that the average rate of change, okay, so the average rate of change, which is our slope from A to B, okay, and so we've got A and B, so we're looking at 2 points. The average rate of change from A to B is defined as that guy. And their idea was, I'm erasing my highlighting, sorry, so you can see the diagram. The idea behind this is that the average rate of change of the secant line is the average rate of change of that section of the curve. So the average rate of change from A to B is defined as that, comma, and represents the average rate of change of the curve. Now, I'll be honest with you, I'm not totally impressed with my explanation of that. So if you would like, hey, I'm honest, if you would like to see how the book defines it, it's on page 87. But the idea behind it, and that's truly what I need you guys to understand, is that if we want to find the average rate of change of a curve, right? So for us right now, it's going to be that. We simply create a secant line that cuts through the curve. So it cuts through at 2 points. We find the average rate of change of that secant line, and that represents the average rate of change of the curve. Pretty rad, right? Oh, don't lie. You think it's rad. You still want to be, that kid in class. It's okay. I know. I see you. I see you. Okay. So how in the world are we going to do this? We'll go ahead and go to example number 5. We're first given the function f of x. It's 1/2 x squared. And we want to find the average rate of change from 0 to 1. Okay, well, we need to first find f of 0, which means we're going to plug in 0 to our function, which works out to be 0. So we can state that f of 0 is 0. Okay, then we need to find out what f of 1 is. We need to find what the function evaluates at each of those points. So we have 1/2 times 1 squared, which equals 1, which means that we have f of 1 is evaluating to 1. At x equals 1, y is 1. Okay, easy enough. So if we're finding the average rate of change, then we're just finding slope. That means I'm going to take f of 1 minus f of 0 over 1 minus 0. You could absolutely do f of 0 minus f of 1 over 0 minus 1. But the idea is that you have the change in your y values over the change in your x values. Okay, so we found f of 1 to be 1, found f of 0 to be 0, and it works out that this is going to be 1 over 1. So that's the average rate of change. Easy? Yes, you're welcome. All right, so let's take a look at another one. 0 to 3. Again, we're finding the change in y over the change in x. So we need to find f of 3 and f of 0 in order to be able to do this. Well, f of 3, that just means that we're going to plug in 3, oops, that's got to be 2, yep, into x. 3 squared is 9, so this becomes 9/2. You can put it into decimal form if you would like. I'm going to leave it as fraction form. And then we did f of 0, and we know that's going to be 0 from the previous one, yeah? All right, so here we go. So that means f of 3 is 9/2 minus 0 over 3 minus 0. Fractions are division, so I'm going to straight out write 9/2 divided by 3. Keep the same, change to multiplication, and flip. I can cross cancel. So the average rate of change from 0 to 3 on this curve, on this section, is going to be 3/2. Yeah. Okay, pause the video. Try this one. Don't be a cheater. Yes, I see you too. Actually pause the video, please. I know you're thinking, I would never. If I'm not there to watch you, who knows? Okay, so pause the video and then replay it and you can see if you were correct. Welcome back. Okay, so hopefully you paused it. If we are to evaluate f of 5, we get 1/2 times 5 squared. 5 squared is 25 over 2. Okay, again, you put it into decimal form if you'd like. I'm leaving it as fraction form. Okay, and we know that f of 0 is 0. Okay, plugging it in, we should get 25 over 2 minus 0 over 5 minus 0. We are dividing fractions, so we have 25/2 times 5. We get 25/2 times 1/5. Again, reduce with me, please. And we end up with an average rate of change of 5 over 2. Okay, and again, that's because we're taking a secant line and cutting this curve into a section. It's not the rate of change for the entire curve. Okay, so the last thing that we need to be able to do, and do me a favor, for example, number 6, cross out C. The last thing that we need to be able to do is write an equation of that secant line. Okay, not hard. All we're going to do is what we did in example number 5 and take it one step further. Okay, so the average rate of change from -2 to 1. First, average rate of change is the change of y over the change in x. So we're going to take f of 1 minus f of -2 all over 1 minus -2. Doesn't matter. You could have done -2 minus 1. That's fine. Just make sure you're consistent in the numerator and the denominator. In order for us to do this, we have to evaluate the function at 1. So I'm going to take 1 and substitute it into the given function. We were given the function at the top for every x. So we get a -2 plus 4 minus 3. -2 plus 4 is 2, minus 3 is -1. Okay, and then we're going to have to evaluate f of -2 to find the corresponding y value. We take -2, make sure you copy down the equation right, and then plug it in for every x. So we get -2 times 4 minus 8 minus 3. Keep going. So we get -8 minus 8 minus 3. -8 minus 8. Are we having fun yet, people? Yes, basic math. Oh, such a good time. Negative 8 minus 8 is negative 16, so this works out to be negative 92. What? We are done. All right. Here we go. Plug in what we know. All to find the average rate of change. So f of 1 gave us a negative 1. F of negative 2 gave us a negative 19. Okay, remember, if I'm going too fast, you can always pause, rewind. All right, don't fast forward. So we get negative 1 plus 19 over negative, over 1 plus 2. Take your time. I'm obviously going too fast because I made a stupid mistake. Go me. Okay, so 1 plus 2. Oh, golly. All right, so then we get 18 over 3. I can't. Oh, can I reduce? Can we reduce? Yes. So this becomes 6 over 1. Okay, so that's our average rate of change. We did this 3 times before in example number 5. So now let's jump to B. And it says find the equation. Well, we've got a couple options. We can use point slope, which sometimes we use, but realistically it's not our most comfortable. So let's use slope intercept. Y equals mx plus b. Okay, we'll use this guy. Well, it says containing negative 2 comma g of negative 2. What? Don't freak out. Same thing that we just did. Negative 2 comma g of x is our function. So of negative 2 we found to correspond to negative 19. 1, g of 1 we found to correspond to negative 1. It's just asking us to find the equation of the secant line that we already found the slope for, the average rate of change. Okay, so pick a point, doesn't matter. I'm going to choose 1, negative 1. If you choose negative 2, negative 19, you will get the same answer as long as our arithmetic is the same, okay? So I'm going to put it into point slope form. So y minus negative 1 is equal to 6 times x minus 1. And we get y plus 1 is equal to 6x minus 6. Y is equal to 6x minus 7. And that is the equation of the secant line. Now remember first day of class, for those that were with us, for if you transferred in, well, this is new. Yay! I said pre-calc isn't hard. The math isn't hard. What's challenging about the course is being able to understand what they're asking you to do, what they're asking you to find. Example number 6 is a prime example of that, because it's saying, ooh, find the average rate of change of g. Okay, so slope, we can do that. But then, find an equation containing negative 2 comma g of negative 2. What? Yeah, super simple, ladies and gentlemen. Don't get tripped up on the verbiage. It's just asking us to take what we found in A and plug it into B. And then put it into point slope form, basic algebra 1. You totally got this. I'm super excited for you. Have a great day. You guys have a homework assignment right now, so you get to do it in class. The textbook is on Canvas for you. Make sure that you get it stamped when you're finished. Okay? Have a great day, you guys.